So we're working with the Pythagorean theorem, solving for the diagonal. We're going to be given a base, a width, and a height. And as Jacob said, the first thing we need to do is cut the base in half. That gives us a triangle. Step 2 is going to be solve for the hypotenuse, or we're going to call it C. So step 2 is solve for C. So we're going to solve for C. So this is where we're going to have to start seeing into 3 dimensions. We found C, we have a height. As I stated at the start, the diagonal we're looking for is front left to back right. So that pink line that I just drew is the diagonal we're looking for. And after we found the C, we have an H, and look at that, we just kind of have 2 legs, huh? And this diagonal that I just drew has become the hypotenuse for the right angle, or the right triangle, that is created with the hypotenuse of the base rectangle, or the base triangle, and then we have our height, and there we have a right triangle. So this red triangle that's just been created, that I'm scratching in, is going to give us the diagonal that we're looking for. So the base, we're going to look for C. The diagonal we're going to call D. So essentially what we're doing here is we're creating 2 Pythagorean theorem problems, and that'll give us our answer. So step 2 is solve for C. Step 3, draw the diagonal. So draw the diagonal and solve for D. So we're going to cut the base in half, creating a triangle. Then we're going to solve for C using the leg lengths that were given. We're going to then draw the diagonal and then solve for D. Is everybody kind of seeing how these triangles are fitting together? Thumbs up if we're understanding how these triangles work together. We're not playing heads up 7 up, Avery. Get up, please. So, we'll work through an example with actual numbers. So we're going to work through an example with numbers, and then we'll try to see if that route is going to fit in the back of our parents' car. So those are the 2 examples we're going to work through in class. Okay, so we're going to work through an example. So go down to the next rectangular prism that we have. So this second rectangular prism that we have, and we are given that the base is 7 centimeters, the width is 5 centimeters, and the height is 3 centimeters. So now we are given our lengths. What do we need to do now? The first thing we need to do, we're going to cut the base in half by drawing the hypotenuse. And now we can solve this like we did solving problems Monday night. So what is our A?
3.
Our A is 5. So we have 5 squared. What's our B?
3.
We're working with the base. So we're going to use the two values. We're not going to use our height until the second equation. So we're going to use the base, two numbers. So 5 squared plus 7 squared equals our C squared. 5 squared is?
25.
7 squared is? 25 plus 49 equals 74. And that equals C squared. We take the square root of both sides. And for when we're solving in 3D, when we solve for the base's radius, or the base's hypotenuse, go ahead and leave it. Don't simplify it at all. Just have it be the square root of 74. Yeah, sorry. So, this will make sense here in a second why we're going to leave it as the square root of 74. So this length right here we just found to be the square root of 74. So now we've found our hypotenuse. What's our next step?
Draw diagonal.
Draw the diagonal. So the green is our diagonal, thus creating our second right triangle. So what's our A? We have a leg here, it's 3 centimeters, and a leg here, square root of 74 centimeters. So we have the square root of 74 squared plus 3 squared equals our D squared. So we're looking for D now. So now, this is convenient, right? The square root of 74 squared is just 74. If we were to simplify that, we'd probably round to somewhere between 8 and 9, so probably like 8.6 or somewhere in that range. And it wouldn't be close to our answer. We'd be off a little bit. So just go ahead, because the square root of something squared will just be itself. So go ahead and leave our C in square roots as just the radical you get when you take the square root of C. And then 3 squared is, that equals D squared. So 74 plus 9 is 83 equals D squared. But when we find D, we're going to go ahead and actually solve. So calculate at work. 83, the square root of 83 is 9.1. So 9.1 centimeters. So this length of the diagonal right here is 9.1 centimeters. Any questions so far? No.
What if you get like 2 radicals?
Like if like there was radicals and a coefficient?
Yeah.
For which value?
A.
If you were given A?
74, you got, instead of 74, you got like 2 radicals 65.
If you got 2 radicals 65, so if you had 2 radicals 65 and you squared 2 radicals 65, you distribute, so 2 squared is 4, and then it'd be times 65, so something like that. So any other questions? Do we see how these two triangles work together to give us that diagonal? So let's try that example that I talked about at the start of class. Go ahead and bounce down to the last box, the last rectangular prism. Because if we have 3 problems in here, it won't fit. I found that out first hour. So, that's why. So, I said that the car was 6 feet by 5 feet by 4 feet. And we're trying to see if our new closet rod will going to fit in our car. So our first step, we're going to draw the diagonal. We're going to cut the base rectangle in half. And now we have a triangle. And now we can use the Pythagorean theorem to find C. So we have 5 squared plus 6 squared equals C squared. So what's 5 squared? 6 squared? So 25 plus 36, I know it's frozen, but we can do mental math. 61 equals C squared. So now we have C squared equals 61, so we're just going to go ahead and take the square root of both sides. And we get that C equals, we're just going to leave it as the square root of 61 for our C's in 3-dimensional problems. So now we have found our base hypotenuse. What do we need to do now? Draw the diagonal. And now we have our second right triangle. So we have a leg, and we have a leg. We're looking for the hypotenuse. So how am I going to write this next equation? So we have 4 squared plus the square root of 61 squared equals D squared. 4 squared is? The square root of 61 squared is? 61. And that equals D squared. (61 plus 16 is 77. That equals D squared. And we take the square root of both sides. And for D, we're looking for a decimal value. And what is the square root of 77? 8.8. 8.8 feet. So, the original question posed, is this rod going to fit in the back of our car? It was 8 feet long. Does it fit? Barely. It's a very tight fit. We have 8/10 of a foot left. So a couple inches on both sides. Yeah.
Unless you perfectly balance it.
Because I'm a smart aleck like that.
Unless you perfectly balance it.
That's cool.
So, tonight's homework, we're going to do something very similar. Tonight's homework, you got a bat from Eric Hosmer at a Royals game, and your brother's a huge fan, but he doesn't live in Kansas City. So you're going to go to the UPS store, and the biggest box they have is going to be a certain dimension. Your job is to find whether or not that bat will fit inside the box. So I'm going to pass that out right now. No, that's the main problem we're doing, and then there's 4 problems on the back. As I pass out these papers, on the back side, on the side that does not have the Eric Hosmer problem, write this at the top and put 1 and 2 under each of the 4 problems. I'm passing this paper out. Once you get it, turn it over to the back side, and at the top right, find both diagonals. All that means is we're doing what we did today. It's just not clearly written on the assignment. So we're doing what we did in class today. But as you get that, just find both diagonals on the back of the paper. And since our problem is oriented a little bit differently than the ones we did in class, go ahead and draw in our diagonals from back left to front right. So both diagonals means just find C and D. On the back side of the paper, find both diagonals. So find our C and find our D. So for our C's, I said keep it as a radical, but for our D's, round to the nearest 10th. So for C's, keep it as a radical, because that'll make it simpler to square. But for our D's, I need a decimal value. So the front page will work you through, step by step, how to do this problem. And along the way, and the last question says, will the bat fit? Is the hypotenuse in the imaginary triangle greater than 40 inches? Braden. I'm sorry? On the back side, find C and find D. So find the first diagonal and the second diagonal. So find your C and find your D. If there's not enough space on that piece of paper, feel free to attach scratch paper. You have about 6 minutes left in class, so you can go ahead and start the first problem, the first couple problems, and work through those. If you have any questions, I will be walking around